Okay, we are going to start. So I invite you to join your seats. Michael, can you hear us online? Can you hear us online? It seems they cannot. They can't hear us online. Really? What is the name of your colleague? But it's not connected. I don't see your colleague. See, these are the people online.
I think I can hear you now.
Excellent. Can you hear us?
Yes, can you hear me?
Yes, we can. Okay, that's perfect. Thank you. Good. So, yeah, I'm gonna keep that. Right. I'm not sharing my screen anymore, it seems. Can you put my slides first? Okay, great. Thank you so much. All right, quite a few people are having a nap after this delicious lunch. Thank you very much for those who are still here with us for this afternoon part of the MUSE Common Final event. This afternoon, we're going to focus on measuring use-based social and environmental impact. So this is the final part of the MUSE project that has started in June 2023. My name is Manon Cohen. For those who just joined, I work at Polis network of cities and regions collaborating for urban transport innovation. And the urban air mobility innovations are definitely an important part of our job. I'm going to be just coordinating all of the speakers today. But before that, I will just introduce you to the event itself. The objective of the MUSE Final event is to raise awareness on the MUSE project, to present and explain the results, and to connect these results with the right audience to support their exploitation beyond the project lifetime. The agenda for this afternoon, so we're now in the welcome part, then we're going to have a brief introduction of SESAR and the context around the MUSE funding program by the project officer. Then we're going to have an introduction to the project itself by the project coordinator. And then we're going to deep dive into the results themselves. After that, we're going to have a well-deserved coffee break, and then a very exciting panel discussion. And finally, the presentation of the white paper, which is summarizing the results and the recommendations for exploitation. A few housekeeping rules at the beginning. It was the same as this morning, but for those who just joined, this event is hybrid, so we have people online and people on site. So in person, please wait for the microphone to speak to make sure that people online hear you. Online, raise your hand if you want to speak. My colleague Zsofia is monitoring, so you're going to have a chance to speak. Also, we want this event to be as interactive as possible, so don't hesitate to raise your hands. When you get the mic, you can introduce yourself when speaking. Online, please rename yourself with your name and your organization. And there is dedicated time for questions and answers after each presentation. And well, the coffee break and drinks tonight if you want to go deeper into the content. Finally, the event is recorded. Please reach out to us if you want to be taken out of the recording, because it's going to be published afterwards. Okay, now just to survey briefly who is in the room. We ask you to raise your hand in person, and online you can click on the raise a hand icon. If you work in the aviation sector. Okay, all right, a bit over half of the room. If you are a noise expert. Okay, we also have some noise experts. If you are concerned about public space occupation, vertiporous location, visual pollution, and privacy breaches. This is a lot of concerns, so I hope everybody feels concerned. Okay, excellent. And just shout out, what would be a priority amongst these concerns? Which one is the most concerning for you? Okay, raise your hand again. Vertiporous location, is that a huge challenge? Okay. Privacy breaches? A bit less. Interesting. Okay. Okay, we'll stop here and we go to the next one because I only have 5 minutes for this introduction. Raise your hand if you work with satellite images. All right. I see several people raising their hand all the time and several people never raising them. So there might be a challenge here. Okay, and finally, raise your hand if you're an urban planner or represent a local or regional public entity. 1, 2, 3, 4. Great. And yeah, if you are or have been involved in projects funded by the SESAR Joint Undertaking. All right. That is actually the bridge to the next presentation because we now have the MUSE project officer from the SESAR Joint Undertaking who is going to introduce SESAR and the funding program. Michael, do you want to share your slides?
Yes, thank you. Thank you very much for that little intro. Unfortunately, I couldn't see exactly how people reacted to the questions, but I had your feedback. Let me try to to share my few slides to introduce. Oops, that's my calendar. Sorry.
We don't see it yet, no worries.
Okay.
Okay, now we see your slides.
All right, good. Let me try and make that full screen for you and stop. Is that visible for everybody?
Yes, perfectly. Thank you.
All right, super. Thank you very much. Right, so I'm Michael Spiroeras. I'm a SESAR Joint Undertaking program manager, and indeed I've been overseeing and steering the MUSE project for the past year. So in that context, I was asked, and I'm happy to introduce a little bit the context within which the MUSE research has taken place. And that means saying a few words about exactly SESAR and the EU funding that, allowed MUSE to be. So for those of you who don't know the SESAR Joint Undertaking, we would have to break down the name or the acronym SESAR, which stands for Single European Sky ATM Research. ATM then in itself being an acronym stands for Air Traffic Management. But in a nutshell, SESAR is the research branch that is looking to modernize air traffic management in Europe, encompassing obviously safety, but capacity, environment, and also in the newer, let's say, aspects of urban air mobility, societal aspects that we will be definitely battling with in the future. Now, how SESAR tries to, let's say, make the research have impact and become a reality and touch all of the citizens throughout Europe. SESAR focuses on what we call solutions, which are operational and technically feasible and deployable and reproducible effectively in all parts or in most parts of Europe, and that are capable to deliver the highest and the most value for everyone involved. A few key figures. So SESAR is doing so by managing a bit more than 600 million euros of investment. We currently have 78 projects running in parallel, MUSE and Maya being two of them. So far, we've got more than 130 solutions delivered, and more than 50% of those have been deployed, and nearly 40% of them are under industrialization. I will tell you a little bit more what that means in a few slides. Now, how this program, the SESAR program, which manages all of these projects running at the same time, works. We have two main axes, let's say, in which we organize. The first one is obviously by topic, and you can see here the portfolios or the flagships, as we call them now. And you can try to guess under which Muse falls under and under which maybe Maya falls under. I don't know if you had a similar presentation this morning, but I will walk you through it. So essentially, you see the 9 main topics with which SESAR is involved. All are very much related to aviation and to air traffic management in various ways. Then the second axis with which we organize the research is by maturity level. And if I focus a little bit on the central box in this slide, you can see here, obviously, the single European sky, the top larger box, which is the overarching European regulation that is the framework for all the work that SESAR and the projects under SESAR do. But if we focus then on the Digital European Sky Program and the SESAR Innovation Pipeline, you can see 3 big pillars that are separated, like I said, by maturity, or otherwise also called technical readiness level. So we've got the less mature fundamental and exploratory research on the left-hand side. In the middle, you can see the ideas and the concepts that have been around for a while that we look into industrializing and maturing them to make sure that they indeed can benefit the ATM world and we can reap those benefits. And then on the right-hand side, the pillar, which is called Digital Sky Demonstrators, which is then taking those industrialized concepts and really creating the critical mass that is needed to ensure the uptake from the industry and from all the stakeholders. At the bottom there, you also see the fast track to innovation and uptake. We select a few projects that we expect can have this journey and progress really in a quicker way. Obviously, this has an added burden, but okay, this is neither here nor there. So if we take the 2 axes that I just introduced to you, then you can see on the left-hand side, you can see all of the topics that we talked I presented earlier, and at the top you can see also the maturity of the research. And so, yes, if we do a cross section there, you can see that where MUSE stands. So we are in the U-Space and urban air mobility flagship or topic. And we are very much in the fundamental research with all the societal aspects that MUSE looked into. But the next presentation will go into that detail. And you can also see Maya, which also stands in the same fundamental research maturity, but in the multimodal flagship there. Now, maybe a last element from me, and if there are any questions, I'm happy to take them, is how we decide which research is going to be performed. We don't decide this on our own. We have a European ATM master plan, which serves as a guideline, which essentially lays down the strategy for the research in the next years to come. And you can see there in the last bullet the time horizons that have been identified in this document. So this is a public document that anyone can Google and really look into more detail as to what the coming research will delve in. And obviously, whatever calls that SESAR puts out need to follow and to reply to the strategic deployment objectives that have been set out in the European ATM Master Plan. We have a new master plan that has been adopted in December 2024, and that is very much now in force since this year. and which is, like I said, essentially our strategy as to what type of research we'll be performing next. And with that context, yes, so here is another page from said master plan where you can see a little bit more the details about use space services and AIM and how the innovative air mobility operations are expected to come into our lives. So I was happy to hear that some people were also interested in the societal aspects, not only the hardcore operational aspects of aviation. And I think that for those people, then MUSE is really the place to be now in the Polis event. Thank you very much. And as I said earlier, I cannot see if there are any questions, so I revert back to you.
Thank you very much, Mikael. Is there any question for Mikael? Yes.
Well, thank you so much, Tobias Biele, Technical University Berlin. I'm just having the question, have there been projects taken over from the fundamental research phase towards the industrialization phase? Thank you.
Yes, yes. It's a very good question. Yes. So indeed, the pipeline, as we call it, the innovation pipeline, has been designed in a way where this is possible. And yes, indeed, this has happened a number of times. Okay, SESAR, we are in the third SESAR, let's say, wave. I don't have exactly the numbers, but I can definitely, I have witnessed, I'd say at least a small dozen of projects evolving from exploratory into industrial or from industrial into demonstrators, not all within the U-Space flagship, but in the program overall.
Very much. Any further question? If not, then thank you very much, Mikael. We're going to go to the second presentation, and I'm happy to welcome on the stage the project coordinator, Miguel. I'll just check this. Okay. Yeah, can we have the slides back? Thank you.
Okay, thank you very much, Manu. And thank you, Michael, for introducing the SESAR to us. What I want to do now is to give you a brief introduction of what this project is about, some context, its objectives and methodology. So first of all, what MUSE stands for. This project acronym stands for Measuring Use Space, Social and Environmental Impact. And as Michael well said, we are part of the fundamental research projects funded by SESAR. We are now at the very end of the project. We are ending at the end of this month after 30 months of research, 6 of them for communication, which is what we are trying to do today, to communicate and disseminate to you what we did, which we hope you enjoy. We are 6 partners in this project. We are NOMON project coordinators. We have also UPC, the University of Belgrade, Polis, ONERA, and IGMFI. But first of all, to give you some context, We believe that U-Space, which for the ones that you don't know, is a set of services that will enable urban air mobility on a wider scale in Europe for a set of different use cases, such as emergency delivery, parcel delivery, or passenger transport, is in a growing scenario right now. But however, in this growing scenario, it's not completely understood the social acceptance and impact of these drones on citizens. So we strongly believe, before creating this project, that there is a need for understanding the interplay between the constant operations of the drones, the impact of UAM traffic in terms of noise, visual pollution, privacy concerns, and other types of impact, and the citizens' spatial behavior and use of public space. Then what we try to do with MUSE is to address this gap and provide the basis for a future use-space service aiming at minimizing these UAM's negative impacts. We have 4 main objectives for the project. First was to develop a set of indicators for measuring these impacts of U-Space. We aim at creating this performance framework for the social and environmental impacts. Second, we also aim at developing methods and tools for measuring and forecasting these indicators previously defined. Then we aim at developing a set of case studies in order to showcase the benefits of the tools and the indicators previously developed in a city in the European region. And the last objective was to create the conditions for transferring this project to next stages in research and innovation. As we have just asked before, we aim at being this project that goes beyond exploratory research. So first of all, we created, as I said, this performance framework. In this performance framework, we included indicators in different areas, such as noise, visual pollution, privacy concerns, access and equity, etc., that my colleague Emir will present later. To give you some hint of that, we had some indicators that look at the number of people impacted by some impact of the drones, such as noise, and other compound indicators that take into account not only the number of people impacted, but also the severity of the impact and the duration of the impacts to get this aggregated view of what is happening. Then we created this impact assessment toolset that is performed that is compounded by a set of different modules, by a module of trajectory generation, then a layer of calculating the impacts of drones, another layer for calculating the dynamic population mapping, because as we said, it was an important objective for us to know how people is moving in public spaces. And then to aggregate these impacts with the population to create the final exposure and indicators. We merge everything together into an interactive dashboard that we will show you later, and you can access online. Here you can see the concept of this toolset. You can see that there are some input data that has been used, for example, the weather or airspace constraints to calculate the trajectories. We also use drone characteristics or 3D models of the cities to calculate noise and visual pollution along those trajectories. And we use other type of data, such as mobile network data, satellite images, land use, to calculate this dynamic population mapping. After this data processing pipeline, we merge both the indicators and the dynamic population mapping to create the final indicators of the proposed by MUSE. We also create these case studies, was the final part of our methodology. We aim with these case studies to demonstrate the capabilities of the methods and tools. We aim also at providing some policy recommendations from the case studies and some lessons learned out of them. We derive our case studies in the city of Madrid for parcel delivery and delivery of medical or emergency supply. And just to finish and to sum up the aim of this project, what we want is to create a tool that can minimize UAM's negative effects. And this can be used by different stakeholders. Some of the ways that we have envisioned are that, for example, drone operators could use this on each of their operations to try to minimize the individual trajectories before planning the flight plans and before going to the use-based traffic manager, which is another stakeholder that can benefit from this tool. This use-based traffic manager can use such a tool to identify flights that do not comply with certain thresholds in noise, visual pollution, other impacts, and request some changes before approval of the flight plans. And finally, policymakers, cities, regional authorities, etc., can use such a tool to identify how policies might be used to improve the life of citizens and to test these regulations in different scenarios before putting them in place. And that's it from my side for now. So thank you very much for your attention.
Thank you. Yeah, I will just maybe ask the other people. You can stay here, Miguel, because now we're going to have the presentation of the MUSE results. Yes. So I will ask our dear partners to come on stage. Sorry. Yeah, Emir and Giovanna, can you come? I think you can just present one after the other, and the others can sit down here so that then the questions can be for everyone at the same time. Is it working? Good. Then I'll just share now Emir's presentation. Is that? Yes. 1 second.
Maybe I can start while Manon is looking for presentation. I can just introduce myself. My name is Emir Ganic. I'm coming from the University of Belgrade, Faculty of Transport and Traffic Engineering. And within the MUSE project, I'm a Work Package 3 leader. Within the Work Package 3, we developed something called, as you can see here, MUSE Use-Based Environmental and Social Performance Framework. So the question for you, why do we need this performance framework? So as Miguel said, we want to minimize the use-based operations impact on social and environmental impact. If we want to minimize something, we need to measure it. We need to know how much it is. So if we want to measure it, we need some indicators, some performance indicators. Therefore, we started building this 2.5 years ago. So at the beginning of the project, we started with this framework. So we didn't start from the scratch. We built upon already some performance indicators in place, such as this PG19 document within SESAR. And why didn't we use just that? So in some different other projects, other scientists learned that the impact is not the same whether you're a man, woman, based on your age. You feel differently noise or visual pollution. Also, privacy concerns are not the same for different population groups, so to say. Therefore, our goal within the MUSE project was to develop performance indicators with the highest possible level of, and then you see this, geographical, temporal, demographic, socioeconomic, and behavior resolution. So we wanted to analyze this interaction between UAM impacts and factors such as age, gender, place of residence, level of income, etc. So this is what this presentation is all about. As I mentioned, we had some foundations. We started asking ourselves what is the quality of life and how these use-based operations impact the quality of life. Then we searched for different academic publications, deliverables from the projects related to MUSE, and finally as a study on the societal acceptance of UM in Europe was document that we rely upon when assessing the different focus areas such as noise, visual pollution, privacy concerns. Okay, so after this literature review, we built initial version of performance framework. It was exactly 2 years ago. So November 2023, we developed this framework and presented it to our stakeholders. Some of our MUSE external expert advisory board members are here with us. They also helped us 2 years ago by giving us feedback on this very same performance framework. We started with 13 indicators, presented, obtained feedback, included it, and finally we ended up with the version that we are presenting you today with 41 indicator, 8 focus areas, and developed measurement mechanisms, which you will hear more about. What you can see on this slide is the comparison with our MUSE performance framework, green one, with the SESAR performance framework, blue one. So as I mentioned, we started from this. This was our basis, and within the SESAR performance framework, we have different focus areas. As MUSE scope was only on environmental and social impacts, we disregarded the areas such as capacity, cost efficiency, flexibility, so we only focused on environment. In SESAR performance framework, there are 12 indicators. We modified 9 of them, 1 we take as it is, and we disregarded 2 as out of scope for our purposes. On top of that, we developed 30 new indicators, and we divided this environment into several focus areas, which we'll talk more about on the next slide. So these are the focus areas that are developed within the MUSE performance framework. First one, noise, you can see the number of performance indicators per each area. So we had noise, visual pollution, privacy concerns, access and equity, emissions, economic aspects, public safety, and wildlife. As within the MUSE, I said that our scope was restricted to some areas. We focused only on these 4, while we also wanted to include in our performance framework for some further projects. Maybe some of you will gain some benefits out of our indicators that we developed here. But to be clear with you, we calculated in the case study for City of Madrid only the indicators for these 4 focus areas. So as I mentioned, the idea is to go into highest resolution possible within this performance framework. So all 41 indicators could be combined with something we called cross-cutting areas. So when you have noise indicators stating the number of people exposed to noise, for example, equivalent noise level, you can also combine that number of people and disaggregate into the further categories within the population. So say the number of men. So if we took the cross-cutting area gender or age, we only look at the senior citizens living in rural areas, or if we want to look only the different time periods during the day, morning, evening, or we differentiate between weekdays or weekends. So our performance framework is giving us the opportunity to filter all these cross-cutting areas in order to tackle the specific problems within the society based on the different research. So now we can go to different indicators. My intention for this presentation, because it's a 10-minute presentation, is not to give you a detailed description of each indicator. You will see all of them, 41 of them, but we will go just shortly upon focus areas. So first focus area is noise, and you can see that within the noise indicators we have some of them called area-based, some of them trajectory-based. The difference is that area-based are more concerned about the traffic itself, and then we look at 15-minute traffic, 1-hour traffic, number of trajectories, and we assess different indicators such as equivalent noise level or sound exposure level. So depends on what we want to assess. We can use different indicators. Also, we have indicator for maximum noise level. Some of them are combining the severity, as Miguel said, severity of the impact, duration, etc. So this is for the noise. Now we can, okay, I didn't say that each table here presents the name of the indicator, unit in which is measured, short description, and the source, whether it is based on our performance framework or modified from, for example, some other research or SESAR performance framework. What you don't see here and what you can see in our other publications is detailed calculation mechanisms. So if you want, for each of these indicators, you can look equations and how to calculate them. For visual pollution, we assess here, for example, the number of people exposed to a single drone operation. These are trajectory-based, or to some UAM traffic within an area. For visual pollution, characteristic is this visual pollution concentration. It is based on the, for example, the distance of a drone from the observer. We also take into account the number of drones in the sky and the size of a drone. The bigger the drone is, the more this visual pollution concentration is. So we have different thresholds. To sum up, you can use all of these indicators for different purposes. And visual pollution is connected to privacy concerns. So if you can see a drone, you can say that you are visually polluted. But the same way, if a drone has a camera, the drone can see you. So somehow you are annoyed, or you could be annoyed by the privacy concerns breach. So we also wanted to tackle that within the MUSE project. And that's why these performance indicators for privacy concerns are based on the calculations of visual pollution indicators. So this is the number of people annoyed by the presence of a single drone operation. We also use here the hovering. Hovering is, for example, when you are at your home and the drone is not cruising or departing or landing, it's just staying at the same height. It makes you more concerned about what he's doing or why is this drone here. So we took all that into account, and there will be, for all of these indicators, afterwards you will see the results of a case study in Madrid. And the final access and equity focus area is something which introduces indicators that are somehow taking into account positive effects of use space operations. So when we talked about noise, visual pollution, they are all negative. But here, for example, we wanted to measure the number of deliveries of goods and equipment to areas with limited or no transport connections during the observed time period. Also, as you can see, I will present later on the emergency delivery case study in Madrid. You will see that drones are quite useful when you want to transfer some medical packages, for example, from one hospital to another. You can actually reduce travel time. For healthcare-related deliveries, we also track that with this kind of access and equity 2 indicator. And then finally, about the equity. So what is equity? In ideal world, which we don't live in, you will have one drone trajectory and all the population in a city will be equally exposed to noise, to visual pollution. Since that is not the case, we wanted to invent or to propose some indicator that will calculate this inequity, so to say. So we want to calculate the deviation of, it could be noise exposure or it could be visual pollution exposure from some mean value. And therefore, we have these 2 indicators also. I will present you that later on. I will not go into more details. I just want to share with you that if you are interested in, you can look at our emission aspect indicators where we tackle CO2, energy consumption, economic aspects. We propose one for positive economic influence, which takes into account new jobs created out of use space operations. Another one is negative, taking into account decrease in property values. So you can also benefit from this performance framework by looking at some of the public safety indicators, and also, as I said, wildlife and impact on wildlife was out of scope of MUSE project. But if you are dealing with these kind of issues and you want to calculate, here are 6 different indicators. For example, you can calculate the total amount of wildlife exposed within some noise contours, or you can track the difference between total amount of wildlife between 2 consecutive measurement periods, etc. So I hope this was helpful for you and useful. I encourage you to visit our paper published recently in Drones Journal, where we explained the use space social and rental performance indicators. Also, here is a link to deliverable 3.1 on Cordis website, where you can see the noise performance indicators also in the deliverable 1.8 of the MUSE project. So thank you very much for your attention, and I look forward to any questions if you have. We can go, okay. Who is next, Miguel?
Yeah, I think it's me, right?
Hey, Joanna. Okay.
Really?
I think the next one is Miguel.
I don't know if it's about results. It should be me.
Okay, thanks. Well, so I want to present now the toolset we developed. As mentioned before, this toolset includes generation of trajectories, the calculation of the impacts, the calculation of the dynamic population mapping, indicators, and interactive dashboard. So starting from the beginning, we first calculated the trajectories for this toolset and for the case studies, because unfortunately we don't have historical trajectories to be analyzed yet. So we use this GEMMA tool developed by the University of Catalonia, which allows us to create realistic trajectories. In the image, you can see in red emergency delivery trajectories between hospitals. You can see that those are performing straight line. You can see in blue parcel delivery trajectories that come from different distribution centers and can go also on a straight line, or might be restricted to a certain airspace structure, such as the one in the middle that is a grid-based structure. Loitering missions can be created as well for surveillance of a certain area. And it allows also for the creation of restricted zones where no flights are allowed, as the pink zone on the top left side of the image. After that, we calculate the different impacts of these trajectories. First, let me talk about noise. Noise is calculated on 4 main steps. Here are the 3 first ones. The first step is to calculate the flight mechanics of the flight based on the trajectory and the characteristics of the drone, the number of propellers, their dynamics, etc. This is done with DINA PVTOL, developed by Onera. Then the noise source are calculated. This is modeled with the Carmen tool, also from Onera, to create an noise emission sphere, which is basically a modeling of all the acoustic sources of the drone in a single sphere. This sphere is then propagated to the rest of the of the area, taking into account urban aspects such as the buildings and so. And you can see on the image how this emission of noise could evolve along a trajectory of the drone. The fourth step I mentioned is to integrate everything to post-process to create some noise metrics to be used by the tool for the final calculation of indicators. We also calculated visual pollution. We had an issue, let's say, in this case, because visual pollution, on the contrary to noise, is not a physical magnitude. It's something related to the ugliness or unattractiveness of what you see, may differ from people to people. So we faced the problem of how to measure this, and we use two different metrics for this visual pollution concentration. One provided by the AirMore project, which takes into account the number of drones visible by the observer and the distance to those drones. And another approach considering the area occupied by the drone compared to the area of open sky. Here on the image you can see how a visual pollution map would look like for a drone flying on that green spot. You can see that closer to the drone the visual pollution is higher, and buildings occlude people to be polluted in their visual line of sight. On the other side, we develop a method for dynamic population mapping. We base on mobile network data provided by Nomon's Population Insight tool, and this was coupled with GPS data. This is because with mobile network data we have a big sample of the population, but we lack some spatial disaggregation. Antennas coverage areas span for some hundreds of meters in the cities, and we use this GPS data to produce probabilistic maps on how to distribute the users detected within each coverage area according to that distribution of the GPS. To have something to compare with, we also calculated the number of people present outside with satellite images. Our partners from IGMFI use some deep learning models to locate, pinpoint people from satellite images in the streets. So this has been performed for 3 different dates. As you can see on the bottom left image, the number of people detected depends on the day, and this is because of some limitations of satellite imagery pedestrian location. Because this relies on the shadows casted by people on the ground, which is what the model recognizes. But the longer the cast of the people, the longer also the cast. The longer the shadows of the people, also the longer the shadows of the buildings, which may occlude some people and make some areas not visible to be detected. Also, this method only allows to consider people when the satellite provides images, which is usually once a day, around 11 a.m. And so we use this tool, these images, for validation of what we got with mobile network data and GPS data. We calibrate first our mobile network data plus GPS with some assumptions. So we assume that people assigned with activity home are inside in residential areas at night, and people with activity work are assumed to be inside during day at business areas. We compare directly our methodology with satellite images, with pedestrians detected from satellite images in big squares of the city, where these shadows are minimized and where this model works the best. We check that adding GPS improves the estimation of people compared to not adding GPS and consider a homogeneous distribution of population inside each antenna coverage area. And after that, we merge what we got with dynamic population mapping and impacts into the exposure diaries of the population. We also calculated other indicators such as privacy concerns, as Emir said, depending on the land use and the percentage of concerned people in those areas, which depend whether the area is residential, commercial, or industrial. And finally, we made available these calculations online with the tool in the link you can see in there, muse.ext.nomon.es. And in here, you can see a video of the tool we developed. Here it is a landing page describing what this tool is about and the project. Then the user will go to the selection of a scenario where we can select between delivery, emergency delivery, etc., and some parameters defining the scenario. It goes to first to the map tab, in which we can see the trajectories on that moment. We can change the resolution of the map. Now it's changed to 90 meters of these grids on the map. You can zoom in, click on the different indicators to see it. You have on the right the total number of people exposed in this case, and you can add cross-cutting areas. In this case, now it looks to the people younger than 25 years, and you can see that the total number of people is now 7,000 people instead of 34. Apart from the map view, there is this dashboard view in which we can see this time distribution of the indicators, distribution by cross-cutting areas, spatial distribution, in this case by district of the city, and correlation between the value of the indicator and some parameters of this case. And that's it for the model side. I think now we can go with the case study results.
Okay, while Manon is managing the presentation, so I would like to present myself. My name is Jovana Kuljanin, and I am an assistant professor at Polytechnic University of Catalonia. So today I'm going to present you some of the results that we obtain along the project. Of course, not all of the results for all the indicators will be presented today, only the ones that we consider relevant and interesting for you. So let's start from the beginning. I am going to present the results from delivery mission. So the starting point of this project was to design the concept of operations. Luckily, we had our colleague Christina, who is sitting here, and she was well equipped with knowledge and experience gained through the Chorus project. So basically, we did a very detailed literature review, and while creating this concept of operations, we were very much inspired by what people did in Metropolis 2, in Chorus project, but also what FAA is proposing. So based on this extensive literature review, we decided to come up with two concepts of operations. As you can see here, on your left-hand side is free route, where basically the parcel delivery will be performed from distribution center, which is located here, and then the trajectory will follow the terrain with some obstacle clearance. And then we have, in this case, in the free route, the delivery will be directly done to the final customer. So in the first case, we don't have basically the vertiports, we only have delivery centers. Then on the right-hand side, you can see something which is called constrained airspace. For this purpose, we created the grid-based network, which is slightly different than the approach they proposed in Metropolis 2. So they proposed street-based, but since the topology of the streets of Madrid did not allow this approach, we decided to go for a grid-based, which basically means that we designed the corridors from east to the from east to the west and from the south to the north, which are embedded with each other. So in this case, we were able to produce as many layers as needed, depending on the amount of traffic that we want to accommodate. It's not necessary to say that all the operations are taking place in BV loss conditions, which means beyond visual line of sight. So this is just a slide to better understand how it works. So for the free route, actually we use the digital surface model, which includes the elevation of the ground and the height of all the obstacles or objects. So in this case, you can see that we try to smooth the terrain a bit. Otherwise, we would have this very noisy trajectory, which is at the same time very energy consuming for drone operations. While in the case of the constrained airspace, we identified the highest obstacle, and then we added some obstacle clearance until we reach the cruise altitude, which is at the end fixed, right? So in the free route, we are following the terrain, so the trajectory is changing according to the surface. While in the constrained airspace or grid airspace, how we call it, it's stable. But it's also operated typically at the higher altitudes. Okay, now I'm going to present you the results from noise pollution. Oh. What did I do? Sorry. Amir already presented all the indicators that we defined within this performance area. I will stick today only to two of them. The first one is NO8, which is actually based on the metric which is called the maximum noise level. And the scope of these indicators is actually traffic. Remember that Amir told you that some of the indicators are traffic-based, taking into account the whole operations, while some other are trajectory-based. So in this case, we choose the one which is traffic-based. So in this case, this NO8, and the one which is trajectory-based, which is this NO3. As you can see in the definition, it's very interesting that you will find this syntax here, which says the amount of people exposed to a maximum sound level higher than a certain threshold. So in this case, we decided that our threshold should be 40 dBA, but policymaker can decide about any other specific threshold. And actually, this is a beauty of this tool set, that many things can be defined upon request. Population presence are depicted here. Actually, all our indicators take into account this population presence. As you can see, we are reaching the peak of 40,000 people outside, somewhere between 1 and 2 p.m. While in order to calculate our indicators, it's crucial also to understand the operations along the day. This is one distribution that we considered. Again, this can be easily changed if there is any other distribution more relevant for the purpose of real flights. So first of all, we would like to present the traffic at its very peak hours, which is between 5 and 6 p.m. Since the indicators is given for a 15-minute period, that's why here we have the noise, corresponding noise map, right? We are, you can see that this area of the same color actually corresponds to the area with the same LA max, right? So this is the same amount of traffic for the free route and for a grid-based network. Okay, so the first indicator, as I said, was NO8. And as you can see, the underlying population map tells us that there are around 34,000 people between 5 and 5:15. And here are the results of NO8 indicator in 2 different concepts of operations. As you can see, according to the results, we have around 18,000 people affected by the noise level higher than 40 dBA in free route, and around 30, or better say 40,000 in a grid-based network. So if we depict the outcome of the NO8 indicator, we can see we are also able to do this with our dashboard. So this is just the screenshot taken from the dashboard, and the policymaker can easily have insight into the distribution of this indicator across the whole day. Finally, cross-cutting areas. So all these results can be further disaggregate into different cross-cutting areas. So in this case, we have the distribution of NO8 indicator across gender. So we consider female and male. Intuitively expected, the women are more exposed than men, but this is somehow normal, since in the general population typically we have more women than men. Maybe a slightly bit interesting results if we take a look at the age groups, so how different age groups are impacted considering NO8 indicator, right? So in this case we proposed 4 age groups, but again this is something that can be configurable upon request. The next indicator, NO3, takes into account a single trajectory. So this is also a very convenient tool if you want just to extract one trajectory and see how it affects the population. So in this case, we on purpose choose the trajectory flying at the very similar altitude, but one is performing in the morning and the second one in the afternoon period. As you can see, according to the results, there is no significant difference between morning and afternoon period, right? So it's also related to the altitude that this trajectory is flying, since there is not so much difference between them two. Sorry. On the other hand, we wanted to demonstrate the difference between the lower altitude trajectory and higher altitude trajectory. And intuitively, you are expecting that the trajectory, which is flying at the higher altitude, will impact less the people on the ground, right? But sometimes it may be just the opposite, and this is a good example of this. So here we can see that the trajectory which is flying at lower altitude actually impact less people than the trajectory which are being performed at the higher altitude. And then, of course, you can ask yourself, why is this? And then the answer can be found actually in the noise map. So if you take a look carefully at the noise map, you can see actually that the higher altitude trajectory actually has less obstacle on its way, enabling the noise to propagate more easily and therefore impact more people. And I think regarding the noise, that's all. So we will switch to visual pollution now.
Okay, so continuing with visual pollution, we also consider two different indicators out of the ones presented by Emil before. One for a single trajectory operation, this total visual pollution exposure perceived by the people, which is measured as the total number of people exposed times the visual pollution concentration times the duration of the exposure. And another indicator for the whole traffic, which just takes into account the number of people exposed, but when they are above a certain threshold of visual pollution exposure and a threshold in time. For this case, we use a visual pollution threshold really low to not discriminate because of that, and a threshold of in time of 60 seconds. For the single trajectory case, we compare the same flight, but when it goes towards the destination and when it comes back. We saw that the forward trajectory has almost twice value compared to the backward trajectory. We saw that this is because of the time the drone takes for landing, which is slower than when it's taking off. So leading to people being exposed during more time, and this indicator being higher in comparison with the backward trajectory. On the traffic case, on this traffic indicator we wanted to show, we compare the two different airspace structures, the free route one with the grid-based one, and we saw that there is a difference of around 10% higher in the grid-based structure, intuitively because it occupies some more space and more people are present in that wider area. For the privacy concern results, we also consider two different indicators, as before, one for single trajectory and another for the whole traffic, but in this case we only look at the number of people concerned. It was mentioned before, but for considering people as concerned, we started with the number of people that is able to see the drone, and we applied a certain percentage of the people to be concerned, as you can see in the annoyed column, depending on the land use. Basically, you are more concerned if you are at your house or a residential area than if you are on a commercial or industrial area. So by making that, we look at single trajectories, two similar trajectories, but with different heights. Similarly, as Joanna presented before, we saw that in some cases, a higher trajectory leads to a higher number of people exposed or concerned in this case. This is because the drone, as it is higher, can be seen from farther away, and it occupies a wider area, then leading to more people exposed. This is because there is no limitation on the there is a limitation on the distance on which you can see the drone, but there is no decay on concerned people depending on the distance. So you are equally concerned, even if you are farther away. We might look into that in further research or to analyze how this could be evolved. And for the traffic case, the privacy concern 3 indicator, we also compare between the two different airspace structures, and we find a similar insight from the visual pollution one, around a 10% higher impact on the grid-based network, which is reasonable taking into account the results from the visual pollution indicators. Now we will switch to the access and equity results, which Emir will present.
Thank you, Miguel. So as you recall, we mentioned that within the MUSE project, we focused on 4 focus areas. So Jovana presented noise, Miguel presented visual pollution and privacy concerns. So the 4th one is access and equity. And you also remember that I was talking about the ideal world and equity. So now we will present the results for these kind of indicators. Here is one simple example to show you how we calculated these indicators. So if you imagine that drone is going ideally here between these 2 zones, and zone could be a settlement or municipality or some 100 square meter area within a city. And if we zone 1, we have 5 persons. In zone 2, we have 15 persons. So some average number of people affected, for example, by noise issues will be 10. And as we said, if equity would be that in each zone within the city, we always have 10 persons affected, which is ideal situation. Here we don't have that. And we calculate relative difference from the mean value or from the average. So in the first zone, we have minus 50% of the people affected from the average, which is 10. And in the zone 2, we have 50% people more affected than the average, which is 15. And you can imagine then in one case study for City of Madrid, we had thousands of zones. So one zone has different percentages. And we wanted to have one indicator resulting the all zones all together. So we invented something called relative inequity, where we sum all the absolute values of these relative differences for each zone, then divide by the number of zones, and then we get the relative inequity. And on the next slide, I will show you the results for performance indicator access and equity number 4, which is based on the visual pollution indicator number 7. So here we are looking at the inequities in terms of visual pollution. So when you see this map, you see some blue zones and some red zones. On the map, you can see that if it's blue, then it means that there are less people than there are on average. And on average, the impact is 40 persons. So 40 persons are visually exposed on some average zone. All the blue ones are less than 40, all the red ones are above 40. In total, when we do the calculation with the equation that I showed, we get for this parcel delivery free route for this kind of indicator average inequity of 89%. Just to remember, if it's 0, then it means that it's perfectly equal. If it's above 0, we have some kind of inequity. So we want to be this number as low as possible. If we are some kind of decision makers, then we can test different kind of airspace configuration, different kind of routes, see what is giving us the least average inequity, and then if we want to tackle this problem, we could use our tools and these kind of indicators. We wanted also to check whether there is some kind of a difference if we change from free route to grid-based. And what do you think? We thought there will be some changes, but then again, this is a very busy period in the afternoon. You can see that there are a lot of trajectories in all parts of the city, so average inequity in this case was marginally different, so 87%. But on some other occasions, we saw some differences ranging from 70, 80, 90%, so you can actually choose which airspace configuration is best for you, or which kind of trajectories work best in terms of this indicator. So this is all about access and equity, and since now I'm also presenting emergency case, all these indicators were about parcel delivery. So we had parcel delivery and emergency deliveries. Within this case study, I will be telling you more about the reduced travel time for healthcare related deliveries. This is also one indicator of access and equity focus area. And here we wanted to subtract the time required for drone deliveries from the time required for the same delivery using road transport, which is mostly used now. So regular car or ambulance car, or in some occasions also motorcycles. So for the road transport delivery, we used in our methodology Google Routes API, and which is similar as you type into the Google Maps and say how much time I need from hospital 12th of October to La Paz, so for example. And then you get one time, and using GEMMA tool, we simulated drone trajectories, obtained different times, so when you subtract them, you get the value for this indicator. For this emergency delivery case study, we used operations beyond visual line of sight. These are urgent and direct flights. Drones is taking off from one hospital, landing to another one. And within this emergency delivery concept of operations, there are two layers. One is at the altitude of 105 meters, and the other one is at 120. So these are the traffic above the parcel delivery. And in this scenario, we focused on 4 hospitals that you can see here, one on the south, one in the middle, and 2 already mentioned on our previous session, that within these 2 hospitals, there were already some demo flights in city of Madrid for ULCOM project. So, okay, this is about our case study. We used 2 different drone types simulating in GEMMA. One was DJI Matrix 600, and another one was Eager Rigitech. And as you can see, they differ mostly. Most important characteristic is that they have different cruise velocities. The faster the drone, the less time it will need to deliver. So this is one important aspect. The other one is also the range. 10 and 80 kilometers. So if you recall the image on previous slide, we here have some distances which are above 10 kilometers. So on hospital pair number 2 and number 3, we were not able to simulate the flights for DJI Matrix 600, which could happen also in the reality. So for the distribution for this case study, we based our hourly distribution on the emergency intervention statistics These data were available from the Samur Protection Civil database. So they track in 1 year. We used the data for 2024, the latest one. They tracked all the calls from 911. There were like 131,000 of calls in previous year. And when you average per each hour, you get this green line. So this is the distribution of these intervention statistics. And we assumed that in the peak hour, which is 1 p.m., we had one flight per each hour between the pairs of hospitals. So sorry, I just wanted to show you this. This is one pair, and it can go in 2 directions. So we have 6 pairs of hospitals with 2 direction forward and backward flights, which is 12. So that's why we had this number of 12. And when you use this distribution, you end up with 180 operations per day, emergency operations in city of Madrid. And when you calculate the mean distance, usually drones flew around 7 kilometers on average, which took them around 7.8 minutes to conduct the flight. And in peak hour, you can see that for DJI we had 7 flights, and for Rigitech 10 flights. Okay, so now we go to the results. What you can see here is the absolute and relative average reduced travel time per each hour. So on average, this is not minimum and maximum values. On average, at, for example, I think this is 4 a.m. in the morning, where there is no traffic congestion, you can expect that the difference between road transportation and when we use drones for delivery, it's 4.4 minutes, not that much. As on the 6 p.m., where there is a congestion, people are coming back to work, going from work, so we have on average 11.7 minutes time saved if we use drones. If we go into relative terms, it's from 35% up to 58% reduction. And you can see that it differs from each hour with peaks around 8, which is usually the traffic congestion time, and 6. Let's go to different metrics. So on this slide, you can see the correlation between hospital road distance and reduced travel time. What this means? It means if the distance between hospital is higher, so if it's like 16 or 17 kilometers, the reduction, the benefit using drone is higher. And also the distribution is, or dispersion is higher. So the reduction could go up to from 5 minutes up to more than 25 minutes, the differences. So it takes some linear slope, and here is the hospitals on the north, only 1 or 2 kilometers apart from each other, so the savings are negligible, less than 5 minutes. It's almost the same if you use the car or a drone. And on this slide, you can see some interesting graphs which are based on the time savings per day of the week. So what do you think? Is it the same if you use a drone on Monday, Tuesday, or Sunday? It depends on the traffic of the city, of the congestion. So logically, we saw some relatively consistent patterns from Monday to Friday, but a moderate decline during the weekends. As you can see, for example, on this, the time saved on average are almost the same, but then decline on Saturday and Sundays. But what is interesting here, what you can see is that predictability is not the same. During Monday to Friday, we are not certain whether using road transportation, we will end up here or here. The difference could be 20, 30 minutes. And if you have some medical deliveries that you need to obtain within the 15 minutes, you are not sure whether you should send a hospital or not. I would prefer to use a drone. So this kind of analysis can be beneficial for policymakers to see on which kind of hospitals, which kind of pairs there is a need to introduce this kind of service. On the next slide, you can see different metrics, but these are not between days, these are between hours of the day. So as I mentioned, you can see peaks around 8 p.m., here at 8 or at 5 p.m. So these are the times where you can benefit mostly by using drones for these medical deliveries. And yeah, these are some stating that the smallest reduction was 1.6 minutes and the largest reduction was 25.7 minutes at 8 a.m., for example, on Tuesday. So this is not about time savings, because at one of our stakeholders workshop, they asked us, okay, but if this is emergency, if I need to transport something, I don't care if I will save time in terms of it's just for me it's important to arrive within the time frame. So if we put some time frame, for example 15 minutes, because in the literature review we saw that the first 15 minutes are critical. If you transfer blood samples, or within 15 minutes something changes and then they are not good to be used, for example. So what this tells you, if you need to deliver something within 15 minutes, out of 180 operations for 7 days in a week, you will always be able to do that with drones. So because all of our operations between each and every hospital pair, between each time of the day, day of a week, the drone, both the type of drones deliver all of the deliveries within less than 50 minutes, which is not the same for regular car, for example, where we see that deliveries took almost 40 minutes. And also we modeled motorcycle and ambulance car times by reducing these regular cars for 10%, 20, 30, and even 40%. But even with 40% reduction of time, you are still not reaching all the deliveries. Here are some of them which are above 15 minutes. So my final slide is that we did some sensitivity analysis and looked for different thresholds. And you can see here that for example, if you need to deliver within 10 minutes of time, with Rigitech that goes, I think, 100 kilometers per hour, you can do this 83% of the time successfully. So again, at some hospital pairs, at some hours of the day, you will not reach these 10 minutes, but then again, it's even better, twice as better than the ambulance car, for example. And as I mentioned, in 15 minutes, it will be 100%. Eventually, in 30 minutes, if it's something not that much urgent, all of these transportation modes will be able to deliver in this case study. So to conclude, the time saved was from 1.6 minutes up to 25.7 minutes. Average reduction was for DJI 7 minutes per flight, for Rigitech a little bit more, 9.6, because it's faster one. And if we multiply this with the total number of flights for these two drone types, we end up with the time saved for only 1 day, for only these 4 hospitals, 10 hours a day for these operations and 15 hours a day. So combined 25 hours of someone's working, driving. But we also wanted to take what is the extra number of extra drone deliveries that we actually could make within these hours. So as you can see, we end up doubling the number of deliveries. So these are some, I think, useful conclusions of this case study, which policymakers could use. And thank you for your attention. If you have any questions, I look forward to answer them.
Do we have any questions in the room? Right. Okay, we can start here.
Nuria Meersgaard from Bax Innovation. So I was wondering, it sounds very cool and interesting, but why aren't more hospitals doing this, or why don't we really see it used today?
Excellent. Thank you. Excellent question. I don't have an answer to say. I can just speculate that the regulation is the problem. Maybe you have more inside information, but the benefit is clear. I think that for them the regulation is the most influential barrier at the moment. I don't know if you can maybe add something else aside from the regulation.
But I would say that there are a lot of hospitals
Yavanna.
who are using.
Yavanna,
Sorry.
yeah,
Thank you. I would say that nowadays there are a lot of hospitals in Europe who are performing this kind of flights. For example, in Geneva, in Zurich, in Switzerland, also in the Berlin. Berlin has a very well-developed network of this because they have, if I'm not wrong, the main Berlin laboratory hospital, and then there are 13 hospitals from which you are getting the samples. If I'm not wrong, they are transporting the blood samples. So among all types of these deliveries, I would say that the emergency delivery is the most prominent one and easy to be further developed.
Yeah, I completely agree with you. I think that her question was also why all these 4 hospitals from Madrid are not doing this right now.
Okay, I didn't understand. I meant that you think on in general, right, on all hospitals in Europe. Okay.
In general, but also why they, for example, didn't continue this pilot, or why they don't do it in general.
And also, I will share with you one example from the city where I live, Belgrade. I have a friend who is oncologist, and she shared with me that for her, one useful case study for this emergency delivery would be when she operates and needs to take the samples out of the patient. She has only like 15 minutes. So she needs to know whether this is tumor or not, for example, and what to do with it. And there is only one hospital in Belgrade that has the operation, how do you say? Operational room, and also the site where they test the samples. And you only need to be in that particular hospital to perform such, and if you are somewhere else in another city or another hospital, you need to have 2-time surgery. And for me, I asked her, why don't you have a drone operation and then just take a sample and go to another hospital, do the analysis, they send you by email the results. And you can imagine that it's not easy like to do that currently. People don't have, I think, trust in the system. They need to change the whole operation to be able to do that. So it will take time, but I think that it's promising, and it should be followed. This direction is something that we should all work on.
Thank you. We had another question there.
Sebastian from IoT Systemics. So for these noise indicators, well, I'm not an expert on this, but there's always this this logarithmic scale. So if it's already loud and you add some more noise, it has a less of an effect as if you're in an environment that is completely quiet. So is this taken into account in some way? Because I can imagine if it's already a street where there's a lot of traffic and it's already really loud, then maybe it doesn't make so much of a difference to add a drone in this context.
Thank you, Sebastian, for your question. Maybe I can answer this because within the performance framework, we had one indicator taking into account background noise. So if you calculate that particular indicator and take into account background noise, which has an effect, you will end up with 0 people, for example. But with every 3 decibels, you can actually hear something. So if the background noise is 50 decibels, you will not hear a drone if you are 52. But then again, your question is on place completely. So we took that into account into the MUSE project. So we have one indicator taking into account background noise. Some of them are not taking into account. So it depends what you want to measure. Sometimes you just want to see what is the impact of drone operations set alone from other impacts. On the other hand, you want to see whether they fit into the background and you cannot hear them. So yeah, I don't know if that answers your question, if you have something to add on.
Maybe we can also have Onera say something to that question. It's fine? Okay.
Yeah, here with us we have Elise, who works for Onera, which is a partner doing the noise calculations within the MUSE.
Okay, thank you. We have another question here.
Hello, I'm Sonia Alves from Mueller BBM. I'm an acoustic consultant, and that's why I'm
Perfect.
And I would have a question. Besides LAQ, LA Max, did you consider psychoacoustic factors as well, such as loudness, sharpness? Because when we are considering UAMs, this becomes relevant, perhaps even more than the absolute LAQ level.
Thank you for that question. This is a question for Elise. I most certainly think that we did not took that into account. Maybe she could answer why we did not. And there were also some indicators, I can say, stating the subjective feeling, which is also important, but we were not able to actually calculate that. That's why we did not use those annoyance curves as you currently have for aviation noise, because those curves are based on some kind of surveys with real traffic. Since we don't have real use space operations and we cannot ask people how they feel, most of those studies are based on the tests in the laboratories. So okay, I will leave Elise maybe to add upon it.
Yes, as Emir said, first of all, we decide not to go into the annoyance direction because it's not mature yet. We need more studies to know the threshold, etc. And we prefer to stick with how to say objective, measurable indicators for now. But obviously, after, when you have to interpret and decide, it will be relevant to go into annoyance curve threshold, as, for example, Giovanna said, when we have chosen 40 dBA as a threshold. It's only an example, and we will have to go into acoustic analysis to go beyond. And also maybe on a more practical aspect, to do noise maps using loudness and precise psychoacoustic indicators can be much more difficult. For example, loudness, you need to have all the frequency bands of your noise, drone noise, and you have temporal aspects, etc. Whereas if you want to model over a whole day for many drones, etc., you use octave band or octave band, etc. So maybe it's also about what you have, how many times you have, but it's also modular. So maybe you can go after, you can go beyond, like you said.
Any further question in the room? Yes.
Hi, I'm Veronica. I work for Minos University with Dublin City Council and the Irish Aviation Authority. I was just very interested in the medical case, and my question was, do you think that reliability is going to change once we have higher traffic? Because the problem of the roads nowadays is because we have too many cars, but we still don't have use space, so operations don't have this volume. Do you forecast changes of reliability? So should we prioritize medical versus the delivery parcels if we are doing the regulation side, or any advice or opinions would be interesting.
Thank you for this excellent question. I can say that from our experience, we also did some simulations with, Christina can correct me, 400, 600 flights, and if you recall, we also our emergency operations occur above the parcel delivery. So regardless of the number of parcel delivery operations, the sky above it is free for emergency deliveries, and also we had 180. When we included to 600 operations, which is really high for emergency, it would mean that you have, I don't know how many emergencies in 1 minute, divided by 24 with our, so in 1 hour you will have like around 30, okay, every 2 minutes. So I don't feel this is in a short future the case, but nevertheless, even if we have 600 operations, I think that we just needed to shift the time for 1 minute, and then you will have free space. So our trajectories crossing each other, and then if you just stay on the ground for 1 minute, you will have a clear path for all of the operations. So at the moment, I don't see that as a real practical problem for emergencies. I don't know for parcel deliveries, what were our conflicts, how many conflicts we had when we increased the number of operations.
Yes, I would add that at the moment we are similar as Maya. We are not considering safety aspects, but through our toolset JAMA, we were able to calculate the number of potential conflicts, which is a first preliminary step for further assessment in the safety area. Because if you are able to identify the conflicts, then at some point you have to provide the tool for traffic resolution or deconfliction. So this is our next step beyond the MUSE project.
And that is the beauty of the research. We just take the assumption that some other project will solve this problem. And we start by saying this is solved, so we don't need to worry about it. And we just want to see the other problems.
Thank you. And do we have further questions? Yes.
Pablo Sánchez from Grida en Aire. First, thank you very much for the detailed explanations of the results. It was very, very well explained. And I would like to know, because you have seen, with respect to the key performance areas and indicators that you are analyzing, that there are some pros and cons. Imagine if you fly higher or fly lower, if you have fly with predefined routes or free route. Maybe it's a little philosophical. I would like to know if you get some conclusions about how you envision the city in the future, no? Which is this Congress about. Predefined, flying higher, flying lower. What do you think?
Yeah, it's a pity I don't have one slide which actually summarizes the noise and visual pollution in two different airspace structures, because at the end we could observe that there is a trade-off. So between visual and noise pollution, and it's really about the priorities that the regulatory bodies will give to some of these performance area. Of course, based on our results, we could see that if we are more concerned about the noise, probably we are going to select the grid-based network. But on the other hand, the results are just the opposite for visual pollution. So it's true that I cannot provide you the answer, but the answer probably resides in the hands of the policymakers and how they envision the future. I would say that we are here to offer the tool which is reliable, which is based on the reliable not only metrics but also the methodologies, and that provides the credible results. But then it also addresses a bit of your question. It's up to policymakers to find a perfect or a good and accurate thresholds and to reassess these networks. This is what I would say regarding this, Amir or Miguel.
I can just add that on our previous panel session, a colleague of ours, Sergi, who is a politician, so to say, he said that usually public has some urge and force government to act on some social issues. So if, I suppose, the citizens are concerned about visual pollution, they will say, please, we dislike this, can you do something about that? And then they use MUSE tool, they check different trajectories, and they say, okay, we now found a solution, we will do this. And maybe 1 year later, then there are some guys saying, okay, but now this is going to our home, and we have much noise. Then they again act, and they change something. And then we end up with equity, because always someone will complain about something. So at the faculty, we have many different classes about trade-offs and about optimization, and so it's just I think the case what you want, and I think that this MUSE tool can help you find out what is the best option, so to say. This was a really political answer, like vote for me.
Okay,
but sorry, we had a lot of meetings with the experts, and I could see that the general trend is to have this free route. Everyone would like to fly in a free route airspace, but free route has some limitations because at the end you will generate a lot of conflicts, right? And then we are entering again the somehow UTM domain, so you have to efficiently solve all these conflicts in a reasonable time. I mean, all the questions that were asked by aviation many years ago again emerged in a different and not in a different context, like in a different clothes, I would say, but they are very similar. So probably we will again try to find the solution in aviation. At least some of the solution are still within aviation. So
it's a very nice conclusion. Thank you, Giovanna. It's time now for the coffee break. So I would like to give a last round of applause to our great partners. Thank you very much. And let's return at 4, so in 15 minutes for the panel discussion. We will start again soon. We will start again soon. So I invite you to come to your seats, and our panelists, you can maybe sit in the front. So I give that to you then. Okay. Or we can put the mic here if you prefer. Good. Okay. Great. So thank you very much for staying for this last part of the MUSE Common Final event. You have successfully reached stage 4. So we are now at the panel discussion, and I am very happy to leave the floor to our partner from the University Polytechnic of Catalonia, Cristina, to moderate this wonderful panel. So. No. Voilà. No worries.
Thank you, Manon, and welcome all of you to this panel that is going to be hopefully very interesting to all of us. As you have seen, we have presented MUSE and the tool set and the performance framework that we have proposed to measure the social impact of and assume drone operators, delivery drone operators, emergency drone operators in the city of Madrid. But the methodology and the performance framework aims to go farther into the future and into many other places, not only in Madrid. So the panel that we have today, the objective is to show, to help, to understand how this tool can help us, you, the people in the audience, in their day-by-day job when you are working on the use space things. So that was our objective. And for this, we have prepared a panel in which we have a drone operator, but it's also a city involved in the city planning. We have USSPs, so the companies that provide services for the urban air mobility to be a reality. We have ANSPs, we have research, people from ATM, from UTM. We have also environmental experts, because we believe that most of the things that we are presenting here is around environmental experts. So I will now introduce each one of our speakers and invite you to come into the stage. So first of all, I would like to introduce Kadri Busov, which is project manager at Tartu Science Park, please. Kadri Busov is an experienced innovation leader with strong background in defense, emerging technologies, and strategic ecosystem building. She currently manages accelerator activities with NATO, Diana, where she supports dual-use startups, including those in the drone sector, in advancing cutting-edge solutions for security and resilience. So welcome, Kadri. Okay, our second invite is Zoltan Vaso. He's an aviation NOx expert at Eurocontrol. Zoltan has 2 decades of experience in aviation performance, environmental management, and operational analysis, having previously worked on aviation consultant and noise performance manager at the London Heathrow Airport. He currently works at the Aviation Sustainability Unit of Eurocontrol, where one of his responsibilities includes the development of drone noise modeling capabilities. So you have, I'm an expert on noise. Thank you. So our third speaker will be Tobias Biele. He's a researcher at the Technical University of Berlin, and he's also creating his own startup, Labor. I'm sorry, I asked for the pronunciation, but it's very difficult. He's a senior research associate at the Department of Work Technology and Participation at the Technical University of Berlin. His research since 2019 has focused on societal expectations and corresponding planning considerations regarding lower airspace and as a new layer of transportation. As managing director of the project and research service provider Luftlabor, Mr. Mille also supports a broad dialogue negotiation process regarding the exploitation of lower airspace through commercial air taxis and drone delivery services. With German's largest rural drone delivery service, March was he and his colleagues successfully piloted how this technology may best be harvested to service the common good. So welcome. Then our fourth speaker is Pablo Sanchez Escalonilla, technical manager at CRIDA, easy to pronounce, easy for me. Technical manager at CRIDA with over 25 years of experience of air traffic management and unmanned air traffic management. Specialized in project leadership, system engineering, and operational validation within the European and RD programs. He has led and contributed to more than 25 international research projects, including SESAR, Youth Space and UAM initiatives, trust advisory at the NAIRE, and participating in the ICAO Advanced Air Mobility Group, representative of European vision in technical exchanges with other countries, NASA, FAA, NEDO, and Korean space, mentor of future talent through ATM research clusters and academic programs in the Polytechnic University of Madrid, and he's recognized expert in sharing strategies in the single European sky air mobility integration with a proven track record on innovation, coordination, and international collaboration. Thank you for being here. And last but not least, we have Christian Schiel Struve, Vice President, Government, Regulatory, and Industrial Affairs at Altitude Angel. Christian Struve has held key positions in the drone industry over the past decades. Most recently, he has served as Vice President of Regulatory and Government Affairs at the British UTM company Altitude Angel, that unfortunately is not any longer there. Previously, he has held roles at the German eVTOL company Volocopter and a leading drone manufacturer DJI also. Where he successfully represented drone users and manufacturers in the regulatory process leading in the European Union for the regulation 345 and 347, which probably was a hard time. So welcome to be here. Okay, so now that I have you all in the stage, I would like to ask you, how do you see all these tools that we have presented in here, all our performance framework, the tool set, the dashboard, the results, the indicators, the thresholds, everything that we have been presenting today in your expertise. So you are working on UTM, you are working in some of the areas of UTM. I would like to, from your side as your stakeholders, how do you see that this can help you in the day by day? Next week, can you use that next week for something? And I will give you, I think was 2 minutes each, 2-3 minutes. So please be fast on the first road. Kadri, you can start, please.
Mentioned here, and I don't think that maybe it is mentioned anywhere, but also ground risk assessment in terms of different kind of drone operations as well. You have civilian drone operations, also you have defense or law enforcement drone operations, which probably have different types of regulations that they need to kind of keep in and make sure, and that let's say the risk appetite is very different as well, and the kind of risk that is allowed is different as well. because I do work in some ways in some civilian drone applications as well within the city of Tartu, but most of my work is with defense and security drones, also defense in the sense of drone detections, and how to make sure that the drones that are actually within how to detect drones that are not registered within your use space, but are nevertheless still moving at relatively high speeds, which have actually happened in Estonia. We had a Ukrainian drone, unfortunately, kind of was misaligned because there's also a lot of GPS jamming, and it exploded on a field. So that would be my very quick rambling answer here.
No problems. You will have more time then later to answer more questions.
No,
okay,
I'm glad to give
sorry for that. Thank you.
The time to somebody else to answer as well.
So, Zoltan, can you explain your view as Eurocontrol noise expert?
Yes, I'll try. So, I think just for those in the room who don't know what Eurocontrol is, so it's the European Agency for Safety in Air Navigation. That's the official name, okay? But actually, a lot of what the title probably contains at the moment has been taken over by the EASA, the European Union Agency for Safety in Aviation. So the name is what it says, but we are responsible, basically, Eurocontrol, for things like the network manager. I think it was mentioned in one of the presentations before, which is effectively the central part of the air traffic management in Europe, for levying the route charges when you're flying through the airspace with aircraft and all this. And there's a branch of Eurocontrol that is dealing with the research, effectively. And part of the research is not just the air traffic management, but also drones and the projects that we're working on. At the same time, are actually they were listed on the slide that were presented by the project officer, by Michael, I think. So there is a lot of involvement, basically, on the SESAR side, especially for drones. So for me, the absolute outcome of MUSE in this sense is this, let's say, not groundbreaking, but it's a shift in the attitude and the shift in the paradigm, perhaps, for the SESAR projects that are going on at the moment and that will come in the future. Not at the moment, because there is a performance framework that's set already. You cannot really change that. It wouldn't be fair to suddenly go and say all the projects that are ongoing need to change the direction and start to assessing all these different performance indicators. However, for the future projects, as the maturity levels are increasing, as Michael has explained, and the drones are still on the table as a whole program, as a flagship, okay, in the SESAR program, then the MUSE really should come in, and the results of MUSE should come in and almost set a new framework. That's my perspective. That's a very personal perspective, okay? But I see a lot of questions that are not being covered at the moment by the SESAR performance framework, and I see them basically all the nuclei, if you like, of the certain new approaches in the current MUSE framework that has been introduced, I think. So that to me is the key outcome. We've got plenty of questions that come after that, which is fine. What does it actually now mean if we quantify all these lovely performance indicators? And how does it affect not only humans, but also the wildlife? Because to measure certain things about the wildlife and say, well, this many species, this many unique animals are being affected by this amount of drones flying from A to B, that's all nice and well, but do we understand what it actually means? So that's, for me, the next step that needs to come after that.
Thank you, Zoltan. So now let's move to Tobias. Can you explain from your position how your come-ups from MUSE?
Thank you. So I found it funny because not in 2 weeks, I was asking, like 6 months before, I was saying, like, can we make this, please, as a tool which can be used for public communication, for stakeholder involvement. I think the MUSE project is one of a kind, and I really like it because it can be used to facilitate participatory planning processes, especially now when there's so much flight trails going on, cities trailing, first flight paths are developed, first hospital routes are introduced. And after all, it's also a social political topic. People are interested about it. They want to be engaged about it. So having this tool as a way to communicate with stakeholders or with the general population on what's happening in their city, what is the expected impact, is just an amazing opportunity. That's why I was asking if this can be carried forward towards a development phase. And yeah, later on, if it can be a comprehensive tool for making proper urban airspace planning, I think this project accelerated. So I think I can use it tomorrow for our Berlin cases and so on. So yeah.
Thank you very much, Tobias. So Pablo, you are at CRIDA, research, ATM, UTM. Can you give your view?
Yes. Just a brief question. Do you all know what EU space is? Are you aware? Okay. It's because, as you probably know, there are several countries that are implemented, are trying to go through EU space and define what they are called EU space airspaces, where drones will receive several services regarding position and so on. And to design these EU space airspaces, it's necessary to do something which is called an airspace risk assessment, an ARA. And two of the pillars of the ARA are fully aligned with the work that you have been doing. One of them is the environmental and the other one is the privacy. So it is necessary to go through the noise, to understand how the noise is impacting in those EU space airspaces that are going to be defined. And I see that these indicators, at least in the first step of the ARA, the airspace risk assessment, should be focused, imagine the noise, on areas where there could be a high impact. Imagine at night, imagine suburban environments where the background noise is not so high. So I see an added value in these short-term decisions that are being taken by, in this case, by ENAIRE as common information service provider now in Spain. But honestly, after today's presentation, I see some more added value. And one of them is to take strategic decisions with high demand. This will be for the future, for the long term, but it's necessary to decide if we will fly with predefined routes, if we will fly high, lower, as I said before. And for me, the last thing that I saw, which is a real added value for the community, for the public, is, I will say an example, because I was coming today with a taxi driver, and I said, okay, I go to a congress about cities in the future, and when I am working on drones and urban air mobility, and he said, okay, but the drones are going to fall over our heads. It's like, and okay, you are defining indicators regarding equity and access, regarding economic aspects, because it is important that the population understands the added value for emergencies, and not only thinking on, okay, what could happen because drones are going to fly over our heads. This is my view.
Thank you very much, Pablo. And finally, Christian, as a US space service provider, expert on operators.
Yeah, I was going to say, I'm going to try and answer this from a general use-based service provider or outside the EU UTM service provider perspective, and say, I think the real benefits for USSPs from MUSE is the methodologies and the indicators that's been explored. So USSP's business is predominantly in the safety and security space, providing aerospace information and geospatial data to drone operators that can facilitate their flights, that can enable their flights. And it's kind of taking the indicators that we've heard presented and a part of the project is taking that to a next level, because it's taking it away from just safety and security and looking at some of those societal acceptance factors that will actually enable the drone industry to grow. And I think most USSPs, you mentioned SIS, but most USSPs will evolve their products over the next years and include, let's say, softer factors rather than just the hard geospatial data. And say, so when you, as a drone operator, buy a service to show where can you fly, how can you fly, what other parameters you need to include for your flight. It goes beyond the traditional safety and security aspect, but it actually goes to the more softer factors such as noise, such as visual pollution, as well as the distribution, the equitable distribution of those factors. So again, it could be used tomorrow, but it's probably going to take a bit longer for all the different USSPs out there to incorporate the methodologies in their product offerings.
Thank you very much, Christian. So that opens a second question, which is the integration of these services. So we are planning to have this methodology maybe converted as a use-based service that is available for municipalities, for citizens, for whatever. And we have to integrate these urban air mobility services first in the air, because we have the air risk, and also in the ground. So the first question is about the ground. How we do integrate this urban air mobility, these drone deliveries with the ground. So I would like to know your opinion on that, Kadri.
I was just thinking, I don't know, a little bit, because I was the first one to answer the first question, so I was a little bit fluttered. But and at the end, I was like, okay, I have some additional insights I would like to add. And before I go to that this question, I think that there is in some ways also a element of how drones are accepted within the, let's say, in a society that also depends whether we like it or not from this geopolitical situation today. And being here in Barcelona, in Spain, which is worlds away from any kind of real, tangible threat at all, right? It's very different than living 45 kilometers from Russian borders where I live, right? And just within our own airport in Tartu, we have very real thing with this, the GPS jamming. It's part of the hybrid warfare. So if there's this GPS jamming, it's 45 kilometers from Russian border. If you go closer, it's even more. So when you're thinking about, okay, well, why don't we want to have this kind of commercial services as drone services, which would be great, which we'd like to do, you know. The appetite for allowing this type of services to be flown in the air is something that even when we're thinking about right now about the ground risk of these drones, when you know that the reality there might be, you know, from 45 kilometers from Russian border, there might be GPS jamming, and maybe you have somebody carrying 25 kilos of potatoes overhead. You don't want them to clash, you know, which is a very far-fetched scenario, but it is not unrealistic scenario. So the way we see it, and working with some government and local government officials as well, it's not that easy to implement a lot of tools from this perspective, merely because even though the tools might be there, but the willingness to take certain types of risks within the urban environments is not.
Absolutely. That's one of the main problems, I think. So maybe Tobias, you can also give your insights about this ground integration. You talked some days before about this municipality view. Can you explain us a little more about how can we deal with this integration of the urban air mobility on the cities?
To reframe the question, just to be sure, you're asking, like, when does the MUSE tool become really relevant because there's so much drone traffic that it's needed, or how did I get it?
No, it's more about, sorry, if I did not correctly explain myself. So you need to integrate urban air mobility. Urban air mobility has to land in the city. And that means you need to have ground facilities. And you have permissions from the municipalities. And you have to involve the citizens. How do you see that integration? It will happen. What's the next step? What we need to do to integrate these ground services?
Yeah. So you're asking for my innovation master plan. I would totally say, of course, we need the software, the hardware. First of all, I think now currently we need some dialogue on what cities want and also what citizens want. So really the question of what do we prefer, what do we prioritize regarding applications. These can be political processes. But then obviously you also say, okay, we have now kind of a goal, so how to do it, how to invest and how to push this to a scale that is relevant on a city scale. So talking about infrastructure, I think if you're talking on hospital and laboratory transportation, everything is kind of manageable. I guess most operators, they just train the clinic staff to do that. But if we are saying our city wants to have a delivery service, then we are really talking about maybe ground infrastructure. We need to talk about how to create standards maybe for mobility hubs that can be open for different operations and different operators and different hardware, most of all. So there, I think in the standardization, we need to have some big effort, which, as I repeat, should come after there's a legitimation, maybe on a municipal level, to go for that. So these kind of two things, I would say, are most important right now.
Thank you very much. Standardization is a key word also in the topic today. And I will jump now to Christian, because Christian, you may have probably both experience. What do you need in ground and what do you need in the air? Also, how do you integrate these flights with the rest of the air traffic? So can you give you some hints about how you see this integration to happen?
I think it's very important to say we have an opportunity not to think about ground and air and sea and what we have as separate domains, but rather an integration. And if we really are serious and we want to, let's say, reap the benefits of transport in the air, be it goods, be it emergency delivery, be it even people, then we're going to have to rethink how we integrate those things in our, in this case, urban transport systems, because rural transport system, let's leave that aside, that's easier. But it's years ago, it's not too long ago, it's some years ago that we saw plans about, for instance, building a vertiport on the roof of Munich Central Station, where people would fly in on autonomous air taxis and transfer to trains and that kind of stuff. I think those plans are buried. I don't think it's going to happen. But at the same time, we've got cities like Dublin and Helsinki where we're actually seeing food deliveries made by automated drones today. Mm-hmm. So it's a bit of a, my views is difficult because we're laying out a path where we have methodologies, we've got rules, we've got regulations, and at the same time, other people are following a track where they're just doing it. And how that's going to converge and what we're actually going to see is going to be pretty interesting. But my years in this business has taught me one thing, that's follow the money. And if the easy money is on coffee deliveries that are, let's say, it doesn't require integration because it's a standalone business, short distances, all that kind of stuff, then that's what we're going to see is going to take off. The more difficult path with person transport and larger goods transport, it's a lucrative business, but it's also something that's very capital intense. And it has much more technical challenges ahead of it than it's got necessarily regulatory and societal challenges. So when that's going to come about, we'll probably have a very mature regulatory framework in place to deal with that when it's going to become reality. I hope that made sense.
Yeah. Absolutely, yeah. So my next question for Pablo. Again, you as an expert of UTM, ATM, how do you see this integration of this urban air mobility in the future?
Yes, really, I was hearing at your words, and it's true. I share this idea of imagining with coffees in Ireland with Mana that are delivering. This cannot be the future of the business, no? But it's true. It's true that for me it's the first step. No? We have to look for opportunities where the market starts to grow, and then the population will start to identify, okay, this is an added value. No? Of course, for emergencies, but maybe for coffees, if you have a coffee in 3 minutes at your home, and it is a good coffee, no? This is important, it will be great. So, and this will be the added value, or the way of starting, but then progressing towards a full integration of operations where the population understands, okay, this is great, this is an added value for me.
Thank you, Pablo. And now, Sultan, you are an expert on the environment. So how do you integrate this urban air mobility with the environment in a nice way?
Yeah, define the nice way. That's I think that's the catch. So there's probably a couple of things I wanted to say, maybe even, touching on the previous points of what was said before. And I think actually, very first point, I'll go back to what Giovanna said, I think at the end, where she said, it's the same problem that we have with the drones now, but it's dressed up in a different way than we used to have, or we still have, with the traditional aviation, okay? So that's a very nice analogy, by the way. It's the same, it's exactly the same thing, except now we don't know what it actually means for certain, like I said, species before, or even for humans, simply because of the duration that these vehicles can actually be occupying your personal space. They can hover. This is not exactly what the traditional aviation does, okay? This is a very different element. So I quite like that analogy there. And what I wanted to say is, of course, the question is, in this case with drones, can we actually get ahead of the game almost and say that everything that we do in terms of use space and definitions and how we get the drones out, how we roll them out, is going to be driven in the first place through environmental sustainability questions and points in mind, perhaps even allowed through or enabled through the MUSE framework as such and the tools that have been delivered there, as opposed to actually doing it in the sort of retrospect, maybe as a secondary effect that nobody really worried about, 60, 70 years ago when the first commercial aircraft started flying out of major hub airports. So for me, that's the key question. What are we doing there for this kind of proactive setup so that we actually get the drones out in such a way that it's probably not minimizing the nuisance or the environmental impact, which is the objective of MUSE, if I remember correctly. That's the opening slide. I think it's the question of the trade-off. What is it that you are prioritizing at that point? Is it the noise over the visuals? Is it the sustainability and the environmental side over ground risk, over even the risk on about the contamination? So we've raised this with my colleagues in Eurocontrol. As Pablo said, we are involved also in the airspace risk assessment process. And there we raised the question of, okay, if you just lose control of a drone, one drone, okay, that's got a lithium battery, and it basically falls into a pond, lake, whatever it is, a reservoir, that is supplying potable drinking water to a community. What then? Well, it's kind of this inseparable element of, it's an airspace risk assessment, but actually it has got an impact on the ground for people that we need to solve. So it's kind of this separation that you cannot really make between the two, between the airspace risk assessment and the ground. So I completely agree with Christian on this. It's a difficult one. So for me, the question is, just to sum up, are we getting ahead of the game, or are we trying to actually do something that we've done always with the traditional aviation, which is kind of, okay, we wait, we see, and maybe it will be okay, maybe it will be not okay. Also, the question of taking the principles from the noise perspective, for instance, okay, taking the principles of the traditional aviation, should we replicate that with the drones as well? Things like flying helicopters over the major motorways, like in the UK, that's a usual thing, okay? Simply to mask the noise impact, because you've got the road noise already. You overlay the helicopter parts over the motorways. Should we do that with the drones? Is the grid-based kind of trajectory in an urban area the most sensible thing to do from the noise perspective, simply because then it masks the background and the road traffic and all the other traffic of the urban environment simply will mask the noise of the drone itself. And does it come at the cost then of the visual pollution, of course? Which one is better? So that's what I'm saying. It's probably not minimizing environmental impact, but it's the trade-off of what is suitable at the given situation or in a given situation. So there's a lots of moving parts, I suppose. It's a difficult one. Huh?
Thank you, Sultan. A very insightful example that we have not measured. We don't have an indicator for measuring this kind of accidents of the batteries falling in the water, but it's a nice thing that may happen and has some effects. So some indicator more than we may put on. So now we have, let me check the time. Yeah, we still have time. My question now is, do you think that we could create a use-based service like the MUSE tool? So can we provide as use-based service providers, and maybe Christian, you are the expert here, and maybe also Pablo. So makes sense to have this new service, and who will be the end users of this service?
You can say if it's let's say the deliverables from MUSE, the results from MUSE, yes, they can be incorporated in use-based services. If it's one single service or if it's spread across several servers, time will tell, but I certainly think it should be. And again, I think it's a dimension that is so important for drone integration that we're not really addressing. And to latch on what Sultan said before, and Joanna was right, that there was many lessons that we can learn from, let's say, crewed aviation. We shouldn't reinvent the wheel. The flip side is that drone integration is taking aviation as we know it, because we designed aviation away from people. We build airports away from people. You go up high, fast, and you cruise without impacting people in general. This is turning this upside down, right? We are taking drones and flying them straight into cities. So the lessons learned, if we can use them, let's by all means do that. But we are going to have to reinvent or newly invent tools like this to make sure that we create urban environments where drones can coexist with people, so to say, because it is people that make our cities. It is people that populate and walk the streets of, be it Madrid or Brussels or Berlin or whatever it is. So I think there's definitely space for building into use-based services. And as I said, one or several, mandated or optional, TBD. Yeah, we'll see that in due time.
Okay, good consultant for the EU regulation. Like Christian is an expert on that. Pablo, how you see that? You believe that there could be a use-based service as part of the provision of services to drone operators, municipalities, and who is the end users of that service?
Really, I see that this could be a service, but I see a service to be provided in the medium to long term, where there is a certain number of drone operations that justifies the existence of this service. And I wonder if the service will be provided by the USSP, as you have said, or by the FISP, no? Because one potential approach is to provide as a centralized service that allows to manage the capacity by means of what you have said, soft constraints. No? This is the point. So for me, this is a way I see, but I see in the medium to long term.
Soft constraint is a key word that we need to keep. Okay, so let's finalize this panel discussion, very interesting panel discussion, with my last question, which is, what are the main requirements for the urban air mobility to be deployed? And which are the first steps that we need to follow now? So maybe we can do, I don't know. So we continue with Tobias, maybe I do the round table.
Okay, how much time we got for this one?
So you have 3 minutes, approx, each.
Okay. I guess then I just summarize my starting statement. I think a clear political mandate is important, which is going a little beyond expert consultation within municipalities, where you're having kind of a dialogue between planners and UAM expert. I think you need to have the bravery to go out into the public. I think there are now good trails on the way to do that. We will go in Berlin out. We will create a citizen assembly with randomly selected citizens, where it's not about pushing stakeholder interest, but considering the common good. That's what I mean. We have a lot of information formats on the agenda to trail drone delivery in Berlin, so we will facilitate this, and I think that similar or alike approaches are important to get this political backup, because if you have it, you can also invest, and I think if you know what you are interested in on a city level, how to create revenue or value, then this can be super important and super helpful to get drive into it locally. Yeah, I think in general what I'm arguing for, I want to get a little bit into the talk with what my successor said. If cities and municipalities have some sort of steering competencies on how to organize their urban airspace, I think things get easier, especially when you have cities who are capable and interested to be first movers. If it's about, I do not know, being able to put your local effort into the airspace organization. If you say, okay, we have some natural conservation and we don't need top-down regulation on how many meters the drone has to fly around it, but you can say, okay, we have what are these big birds? Bird of prey. If you have some bird of prey, some hawks or something, and you have local initiatives saying we need at least 300 meters, 100 meters is too less to fly around their nest, whatever. You can have this local knowledge facilitated to make good urban airspace planning, and therefore you need some steering competencies, and if this is provided, rather from a bottom-up approach, I think this will help a lot to create urban air mobility forerunners, which I think would still be helpful to push the industry overall. That's my take. Thank you.
City involvement is key, of course.
I guess so.
Sultan.
City involvement is key, and perhaps what needs to come before that is this debate about what kind of regulation, if any, needs to be at the European level. I think Sergi said that in the previous panel. He was a big advocate of that. So I'm not saying that's the right thing to do, or if that's the way things should go, but there will be this discrepancy, that's for sure, between the national interests and the national regulations as we have at the moment. And in a way, perhaps MUSE at the moment is kind of being put the hands away, if I say it like that. So in certain ways, when you look at the framework, it says, okay, yes, 40 decibels in brackets, but fill it in with whatever you want. Okay, so that's kind of thing. So it's a bit alibistic approach in a way. Okay, not in a negative sense, but that's how it transpires effectively. Okay. So yeah, there's going to be always the national kind of question and say, okay, so what does the authority of any given country say on this, and what do they fill those brackets in with in the first place, versus this question of, okay, should somebody come from the top and say, okay, well, when you are doing airspace risk assessment or the specific operation, the SORA, the specific operations risk assessment, the metrics or the framework, or part of the framework of MUSE to be taken into account is X, Y, Z, okay? And you are supposed to fill it in with the numbers that are at least this or maximum that, something like that. So give a bit of a boundary. So that I think, is the key question here. How do the two things meet, and how are we going to make that happen? So from the Eurocontrol perspective, we would absolutely love to see, something that's, because we like regulation, of course, and we like regulation in Europe in general. So let's also say that we sometimes over-regulate, and we've got that tendency. So yes, we would like to see something that's basically cascading and setting the things at the top, and then says, okay, well, when you are a country, you need to adopt this and that in such fashion. However, it's a difficult subject. And the other thing, the immediate sort of question for me is, again, this just going to re-emphasize what I said at the beginning, is the follow-up work now. Okay, fine, we are quantifying certain metrics. We can put numbers on X, Y percentage of your field of view is being obscured by this number of drones within these 15 minutes. That's all nice and well. However, what we don't know at this moment in time is how is this affecting the human beings and the wildlife at the same time. And this to me is a critical point in actually being able to move forward, because then you can actually say, fine, if you take then your framework and then you put in the impacts. So yes, we are talking highly annoyed people. We are talking annoyance. That's all nice and well. Again, what are we talking about when we say this, take the one planet principle? What does it actually mean? So for me, that's where we need to go.
Thank you, Sultan. Kadri, what you say from the perspective of Tartu city?
Well, I would like to bring together, say a quote that I know a lot of people have heard a lot, and I really don't like it, but I think that is appropriate here, is that US innovates, China replicates, and Europe regulates. And I don't really like this quote a lot at all, but I do understand that when it comes to, in any kind of drone applications and services, to be able to fly in Europe, we're already on a path of having excessive amount of regulation, and we're looking for cities and places who are willing to do things that are not aligned with these regulations. And also you mentioned Dublin and you mentioned Helsinki, but you didn't mention Vilnius. Vilnius actually done quite a lot of things with drones as well, but from a different perspective. They have used drones to gather data, not as a product themselves, but as an enabler to build data centers that will help with smart city planning, because they can, do overflight with drones and gather all kinds of data, which kind of puts them in crosshairs with GDPR, but they didn't really care too much, and they did it anyway. So I think that when we're talking about these things, and I've had a lot of discussions here back in Tartu as well with different drone innovators and service providers, and would like to provide and develop different kind of services. The appetite, let's say, to follow the rules and regulations is very, very different across different EU countries and local governments and such as well. And different national regulations also make it create differences on how you implement GDPR, for example. It's not, because it's, even though that it's across European, applies everybody equally, still it dependent on the national regulations as well. So what to do? And I think that maybe one thing that hasn't been mentioned here, but coming back to this lithium seeking into water, another thing that also creates a lot of pollution is the FPV drones with their fiber optic cables that will remain on the ground and create this kind of little, and this can actually be very, very harmful for animals. They're not being used in Europe in a sense, because we're talking about battlefield drones for the GPS jamming. However, they are slowly seeping into Europe as well. So if you have drones that have 20 kilometers of these fiber optic cables, which are thin as a human hair, yet it remains on the ground, nobody going and kind of cleans them up. So the question here is how do we generate and how do we allocate liability? How to allocate, what is a liability, like actual monetary liability? If this is your drone, it falls into this pond or groundwater, and you start having this harmful chemicals sweeping into the in the ground and poisoning wild animals or whatnot have you around it, how do you make sure that who's liable for this kind of pollution? So in order to do that, you have to make sure that every single drone that is flying has a tag that you can follow it. So and now we come to the difference from the commercial aviation, because the entry barrier for commercial aviation is very high. You probably will not have Boeing 747s flying around, you don't know who owns them. But you can have a bunch of drones flying around, you don't know who owns them. How do you make sure that every drone is counted for? How do you make sure that every drone is counted for has a liability or insurance or however you want to factor it in, so that if something happens, whether it is on harmful chemicals in groundwater or a lot of fiber cables across huge spaces, how do you allocate liability? And if you start allocating liability, you will probably see certain types of behavior changing very quickly.
Liability, good, a new keyword to keep. So just to finish the round, Christian.
I think Kadri was spot on. I mean, we've had 3 responses so far, and they're very much on the regulatory side, right? So that's probably a European thing. I'll take a different angle, because regulations are certainly important, but I do think, and as Kadri said, it's going to, UAM adoption is going to move in different paces across Europe, because there is different appetite for all sorts of different risks, and there is different innovation paces, etc., etc. If it's Helsinki and Dublin that are going to come out first, or if we're going to see something else go in a different direction, we had earlier the mentioning of intra-hospital deliveries in Berlin. Who knows? But it's for sure it's going to move in different paces across Europe. I honestly do not think we need more European regulation, because we are already seeing that the existing regulations being implemented in many different ways across Europe and interpreted in many different ways. So if we need more European regulation, it for sure needs to be a framework that can be implemented in exactly different ways. But we're probably, if we're going in that direction, it's probably going to be something more, as we talked about earlier, representative of citizens and cities. So you get local customs and local circumstances taken into account. And see, I ended up answering something about regulations anyway. So yeah.
Pablo, the last view.
Maybe my final thought could be related to the use of the indicators coming from MUSE, because I think something that we need to ensure is that finally they are representative enough of the way of thinking of the population. If finally we decide, okay, let's use it, we have to guarantee that really we are capturing the expectations. For instance, with regards to noise, you have said something about other type of indicators, the frequency. There are other things, because everybody is concerned about the noise, but it's true that with the background, well, in the downtown, maybe this is not relevant, but in other areas and thinking on other indicators, they will be highly relevant. And this is where we have to put the focus.
Thank you very much to all the panelists. I will try to wrap up in 2 minutes all these interesting things that has been said. So we have several proposals for using the framework, the performance framework, from the different perspectives. But still, we need to go a little deeper. So we have this hands-off. So we have sometimes not going to the final detail of which is the threshold, which is the different values that makes something be adopted or not. And for sure, we need the involvement of the population. That can be cities, but we need this debate. So something that I can take away from this is that we need to talk more about these concerns on your space, because if we don't talk about the concerns, no one will think on the solutions. So the first thing is to make debate and try to make consensus of the people, try to obtain these soft restrictions that we talk about, these trade-offs, what's worse in one side or what the other. And that's the takeoffs that I may take from very interesting conversations and views from you. So I would like you to make an applause to our panelists for the great job they did.
And thank you very much, Christina, for your brilliant job as a moderator. Okay, so is there any question for the panelists from the audience, maybe? No? And online also not? Okay, then, yeah, you can join the audience again. Thank you so much. Thank you. And yeah, it's almost 5, so we're gonna go to the last part of this MUSE final event, which is the introduction to the MUSE white paper, which is titled, well, I will show you. Okay, this is again a test cover and is going to be changed, especially since this one has wrong logos. But it was just to give a nice illustration to the document. So the MUSE white paper is titled Measuring Use Space Social and Environmental Impacts, Lessons Learned from MUSE and Way Forward. Once again, it's the wrong logos, all right? So don't disseminate that too far. So objectives of this document should be maximum 30 pages long. So we're gonna cut down a lot. But yeah, the idea is to make a summary that is usable for the target audiences in order for the results of the MUSE project to be more easy to use after the project. So 3 main objectives, just like for the Maya white paper: provide a high-level view of the main results of the project, promote the conclusions of the project and the deriving recommendations, and support exploitation and further development by the target audiences. The timeline is also the same as for the Maya project, so we're gonna finalize the document and submit it to the SESAR Joint Undertaking by end of this month, and it's gonna be published in the coming month upon approval by the SESAR Joint Undertaking. The structure is similar and not similar to the Maya white paper. So we also have an introduction, a conclusion, and 3 main parts. But of course, the 3 main parts are different because the structure of the project is different. So the Maya project had 3 distinct tools. The MUSE project has 1 framework and 1 toolset that is then like presented in a different way than the Maya results. So I'll just go parts by parts. Yeah, so in the introduction, we have 3 parts. First one is about setting the context, explaining why we need MUSE, and the potential of UAM services, as well as the current acceptance status by citizens, because there is a lot of public acceptance studies in the European Union. So we are trying to summarize this to highlight what is needed to better understand this public acceptance and the challenges related. So that's just like the introduction to why we need the indicators and to measure these indicators. And then there's also a brief overview of the currently existing impact assessment tools and what is lacking. So what the MUSE project has tried to solve in developing our solutions. And especially developing less generic and less aggregated indicators, especially through the cross-cutting areas that Emir has presented. And we also, yeah, the MUSE tools have developed specifically an interplay between the UAM concept of operations and citizen spatial behavior, thanks to the use of satellite images that were presented but were not so much asked about in the room today. But this is also quite an added value of the MUSE projects that is highlighted in the introduction of the white paper. Yeah, and then the rest of the introduction is about presenting the aim of the MUSE projects, the settings, when the project happened, what was the funding, what were the outcomes, who were the partners involved, and the objectives of the white paper, as well as the target audiences and the structure. Okay, then the first part is focusing on the role of MUSE in use space and UAM in general. So the first idea is to understand the sub-objectives of MUSE. So define the set of performance indicators, develop the methods and tools to measure them, showcase the capabilities of these tools, and finally create the conditions for transfer and exploitation of the results. This is basically information that you had already today. The second part is about defining more particularly what is meant through the MUSE objectives. So it's called measuring use space, social and environmental impacts, but the impacts that have been measured actually were related to UAM services in addition to use space. So there's also this distinction made in the white paper. Then citizens' quality of life is defined based on the work that has been done for the performance framework development. And then the connection between the description of the definition of quality of life and the related work on the cross-cutting areas. And finally, the impacts assessed and the ones that were not assessed, in relation why we have assessed specific impacts and not others. So why we have focused on noise, visual pollution, privacy concern, access and equity, etc. And so the last part of this, like MUSE in USpace and UAM, is focusing, like just presenting more concretely the outcomes of the project. So the performance framework, the decision support framework, and then the sets of lessons learned and recommendations, which is included mainly in the results of the case studies and the white paper. So the second part is focusing this time on the role of USpace and UAM in society more globally. Okay, so we start from MUSE in USpace and UAM, and then USpace and UAM in society. So why we need UAM and the case studies that we have developed in MUSE. So we have imagined where UAM would be useful in society. This has been done in other projects, but I think it is important also for non-informed audiences that are also target of this document to understand why we have defined these scenarios and what benefits they would bring to society, in addition to the impacts that we have calculated. And that's why this is divided in 3 main parts. So UAM purposes and the related service characteristics. So here I briefly introduce the scenarios used in MUSE, focusing on parcel delivery and emergency delivery, and for each case explaining the context that have been imagined. So we would need parcel delivery in that type of framework, from city center to outside of the city center, at that time of the day for this type of customers, etc. The related concept of operations, the scenarios that have been simulated in the tool of Universitat Politècnica de Catalunya, and the benefits expected for the citizens. So this for both scenarios. So the first part is about these scenarios, and the second part is about the results that we have to obtain in simulating these scenarios. So for each scenario, parcel delivery and emergency delivery, what are the impacts that have been assessed? A very brief summary of the results, and especially the deriving recommendations that are extensively discussed in the simulation deliverable, but that should be summarized here to be targeted to the people who should hear these recommendations. And the last part is about wider consequences on society, because so we have calculated some impacts, we have derived some recommendations, but what are the consequences of these impacts on society? And this relates also to the questions about psychoacoustics, for example, noise. What are the consequences of noise on public health, for example? And so why is it important for decision makers to take that into consideration? So that's the link between noise and health, for example, but then also access and equity indicators. Why are these access and equity indicators important when working on spatial planning in a city? Privacy concern, what is the connection with GDPR and how to handle like the data that is produced? Because people are annoyed by drones, but what is the real risk for their privacy, and what are they exactly concerned about? Why, and how to address this, because there is a regulation that is already addressing this. So how is this regulation also connected to potential privacy risks related to drones? And finally, some considerations related to emissions and energy, because this was not part of the performance indicators that we have developed, but it is also very important in the impacts of drones on society. Okay, and so the last part is supposed to be organized by target audience and very practical, usable for the target audiences. So we have identified 6 main target audiences, and for each target audiences, we try to make a summary of what exactly the MUSE tools can be used for. So for example, drone manufacturers, pilots and operators, refine aircraft model, integrate flight constraints, be aware of citizens' perspective. For USpace service provider, integrate a new service, include refine information on operations impact. For aviation authority, collect data to define threshold and regulations. This has been said before. Municipalities and regional governments to understand the potential impacts of drones, understand also the operational constraints, especially through understanding the scenario development, and then collect data, just as for the aviation authority, to define thresholds and regulation. And finally, for the research and development institutes and funding institutions, so the MUSE work has touched upon several sectors, and there have been advancements in these different sectors. So I just here put the list of the sectors: noise modeling, satellite imagery analysis, mobile network data analysis, trajectory generation, concept of operations, and performance definitions. These are all distinct research sectors that have been interlinked in the MUSE project, and this is already quite an advancement that should be taken further. And finally, synergies with other projects and clusters in SESARs. So the clusters that already exist, that have been used in MUSE, and that could be developed further. So that is the last part, and then we go to the conclusion of the white paper. Okay, I didn't put the slide about the conclusion, but in the conclusion, I'll just go to the first slide about the table of content. We separated it in two parts: the future research needs and insights for future UAM services. So we have talked about the cities where the services are already happening, and we also have talked about the fact that cities will be very different from each other, cities and regions actually, that the local context is extremely important for the development of UAM services, and to assess impact, it is also extremely important. So it will be very difficult to assess impact the same way across all cities and regions. And this is what we want to highlight here in the last part of the MUSE white paper. So that's all as a summary of the content of the white paper. The same question as for Maya. Do you see any target audience that would be missing from the list? Like other stakeholder types that would be affected by the impacts of drones and the indicators used for that. Yes, you can say it louder. Mm-hmm, mm-hmm. All of our Europe, and they should decide what municipalities and regional governments can do and cannot do. So I think somehow the outtake that there is some steering needs on the local level, it should be communicated to them, not to the municipalities only. So the civil aviation authorities at national level. Yes, I agree. Mm-hmm. And actually, the European authorities don't appear here. So this is also something, indeed. We should have like different governance levels. That's true. Thank you. Yes, Sultan? So citizen representatives. Excellent. That's true. Okay. Different governance level, community groups. If, yes, Ricardo? Yes. So the World Health Organization, we have